Hello, welcome to my channel Math with Nazia. In this channel, you will find a lot of tips and tricks across all the topics in math. If you are new to this channel, click on the subscribe button and hit the bell icon so that you get a regular updates of all my videos. So in today's video, we are going to learn about trigonometry. So this is a very important chapter. So first, let's see what is trigonometry. So trigonometry is nothing but it's a Greek word. It's a Greek originated word. It is divided into two parts, trigno and metry. Trigno means triangle. So we use this in triangles. Metry means measure. So we are going to measure the triangles. So triangle has three sides and three angles. So trigonometry is a study of a relation between the sides and angles of a triangle. So we are going to study the relation between the angles. So it has three angles and three sides. So we are going to study the relationship between these three sides. Now, usually students ask, why do we learn trigonometry and where are we going to use this? Right? So for example, you are standing here in the point A, and there is an Eiffel Tower here. This B and C is an Eiffel Tower, and you want to know the height of an Eiffel Tower. So you can't take a tape or something to measure the Eiffel Tower. So instead, you can know the distance, how far you are from the tower and this angle. So using the distance and the angle, we can find the height of the Eiffel Tower. So trigonometry is used in our day-to-day life to find the distance. We can also find the distance from the ground to the person, or we can find the height of the Eiffel Tower. So trigonometry is used to find the height, distance and the width from a particular place instead of measuring just by using mathematical calculations. So trigonometry has a specific role in our day-to-day life. And as you could see, we apply trigonometrical ratios and all the things would be done only in a right angled triangle. So we use trigonometrical ratios and trigonometrical measure to find for a right angle triangle. Not for any other triangle, it is only for the right angle triangle. So you will understand as we start doing our questions. Now let's take this triangle ABC, which is a right angled at B. So B is 90 degree. As I have already told you, in trigonometry we will apply only for right angles, right? So now let's start naming the sides. So this is a right angle. So the side opposite to the right angle is always the hypotenuse. I think you all know this. We have already learned in Pythagoras theorem. This is the longest side. So the side opposite to the right angle is called as hypotenuse. Now we are going to take any one angle. So now let's take this angle A. So when I'm going to take this angle A, so we are going to do it in reference to angle A. So with reference to angle A, so the side exactly opposite. So this is the angle exactly opposite, which is BC. This side is called as the opposite side, or you can call it as the perpendicular side because it's a standing line, because it's a straight vertical line. So either we call it as a perpendicular or we call it as an opposite. Usually we use perpendicular, but few use opposite. So the side exactly opposite to the reference angle is the opposite side or the perpendicular side. And the side which is directly adjacent. Adjacent means which is nearby. Usually the word adjacent means the nearby side. So with reference to angle A, AB is our base. Now we have named our side. AB is the base, BC is the perpendicular and AC is the hypotenuse. Now in trigonometry we use like sine, cos, tan, cosec, sec and cot. So these are the new terms which you are going to learn. So we have 6 trigonometrical ratios. So let's start writing the 6 trigonometrical ratios with reference to angle A. We can do it with angle C also. That I will teach you the later part. So first let's learn with the reference to angle A. So first is the sine A. What is sine A? Sine A is nothing but perpendicular by hypotenuse. That is P by H. Easy. Sine A is nothing but perpendicular to hypotenuse. Then we have cosine. Either you can write cosine or you can just write cos A. Usually cosine will write it as cos, but when the actual word is cosine, we write it as cos. So cos is nothing but base by hypotenuse. Isn't it easy? Sine is perpendicular line by hypotenuse. Cos is base by hypotenuse. Easy. Now let's see the third one, which is the tan. Tan A. What is tan A? Tan A is nothing but, we will not take a hypotenuse here, we will take perpendicular by hypotenuse. Sorry, perpendicular by base. Pretty easy. You can just remember this. Sine A is nothing but perpendicular by hypotenuse. Cos A is base by hypotenuse. Tan A is perpendicular by base. Easy. Now the other three are just the reverse of this. The reverse of sine is cosec. We have a cosec A. What is cosec A? It's just a reverse of sine A, which is hypotenuse by perpendicular. We just need to flip it around. And what is the opposite of cos? What is the reverse of cos is? Sec A. Sec A is the opposite of cos. So here also we will just reverse it, which will be H by B, that is hypotenuse by base. And the reverse of tan is cot. Cot A is B by P. Isn't it very easy? You just need to remember the first part. Once you remember the first part, you have to just reverse it for the cosec. So you have to remember this. The opposite of sine is cosec. The opposite of cos is sec. This is little different. So usually students confuse the opposite of sine is sec and the opposite of cos is cosec. No, that is not the way. The opposite of sine is cosec and the opposite of cos is sec. So please remember this. So this is with the reference of angle A. Isn't it very easy? Now I have drawn the same triangle again. I have not changed the side. So this is for you to understand, so that you have the reference, both a reference, and you can understand this easily. The same triangle, it is right angled at B. So since this is the right angle, which is our hypotenuse, right, AC is our hypotenuse. So hypotenuse is the same. There is no change in this. Now earlier we took the reference angle as A, right? Now we are going to take the reference angle as C. So here the reference angle is C. So which is our base and which is our perpendicular? The side directly opposite to the reference angle. So the reference angle is C. The side directly opposite to the reference angle is our opposite side or perpendicular. So here AB is our opposite side or perpendicular. And the side adjacent, that is next to it, which is whichever is close to it, that is the base. Easy. Whichever side there, whichever angle, whichever is the reference angle, just opposite to it is a perpendicular, and which is next to it is a base. This hypotenuse will never change. It will remain constant. Only these two flip around. Right? Now let's write the same six trigonometrical ratios with reference to angle C. So I'm writing all this so that you don't get confused in this. This is the basic of trigonometry. You can be very clear in this. So once you are clear in this, you can do the trigonometry very easily. So now the same way sine C. So now I'm going to take sine C. So sine C here, again the same formula, perpendicular by hypotenuse. So which is our perpendicular side here? Our perpendicular side here is AB. It is not BC. It is changing. Here it is AB by AC. So this is a difference. The same formula is same, but the side changes. Here I have not written the side because you understood for the first time. Now to compare, I am writing the sides. So sides is not necessary to write. It is only for your understanding. Same way now, what is cos C? Cos C is the same formula, base by hypotenuse. So here what is our base? BC. So it is BC by AC. Easy. It's the same, only the sides are changing. Now tan. What is tan C? Perpendicular by base. What is our perpendicular here? AB. AB by BC. Easy. And the reverse of this is cosec, sec and cot. I think you will be able to write that easily. So it is just that you remember the first three formulas, and one point to remember is the side exactly opposite to it is opposite side or the perpendicular side. The side which is next to it, that is the base side, that is which is adjacent to it. Pretty easy. Do not forget this concept. Angle, whichever the reference angle we are taking, exactly opposite to that is the perpendicular, which is next to it is our base. Be pretty clear in this. This is very basics of our trigonometry. Now let's do few questions related to these trigonometrical ratios. Now let's see the first question for today. In a triangle, a right angled at A, if AB equals 12 cm, AC equals 5 cm, find all the 6 trigonometric ratio of angle B and C. So we have to find trigonometrical ratios of angle B, all the 6 trigonometrical ratios like sine, cos, tan, cosec, sec and cot. We have to find all the 6 for B as well as C. I am taking this as a vast question because so that you will understand how do we form the ratios for B and separately for C. Right? So this is our picture given, the figure given. Triangle ABC, right angled at A. So whichever angle is right angled, that you will put here. This is the right angle. And what else is given? AB is 12 cm. So this is 12 cm and AC is 5 cm. So now first we have to find with the trigonometrical ratio with B. So when we put B here, when we take this as a reference angle, what have I explained you? Which is the opposite side? Yes, this is the opposite side. This is either called as opposite or perpendicular. We usually write it as a perpendicular side. And this is our base. But what about our hypotenuse? Our hypotenuse side is missing here. So how are we going to find? How are we going to find the hypotenuse side? Any idea by seeing this triangle? Right. We are going to use our Pythagoras theorem. I hope you all remember the Pythagoras theorem. We will use Pythagoras theorem and find the hypotenuse. So first we have to find BC square. So BC square is equal to AC square plus AB square. So the square of the hypotenuse is equal to the sum of the squares of the other two sides. So here we have AC square is 5 square plus 12 square. So 5 square plus 12 square is 25 plus 144. 125 plus 144 we get it as 169. So BC equals, since there is a square here, squaring on both sides, this will give 169, root of 169. So what is root of 169? So BC equals 13. So to do this trigonometry, it is better if you remember all the square numbers. What is 5 square, 12 square, 13 square, till 25 square. This will be really helpful so that you are able to find the square root and you are able to do the square. So now we have got the value of BC as 13. So we have got the hypotenuse as 13. Now let us find out all the 6 trigonometrical ratio with reference to angle B. So we are taking the angle B. So we know which is our perpendicular side, our base and our hypotenuse. So since it's reference to angle B, we are going to find out sine B. What is sine B? Perpendicular by hypotenuse. So what is our perpendicular here? 5. So it is 5 by 13. Then we are going to do cos B. What is our cos B? Base by hypotenuse. So what is our base here? 12. 12 by 13. So I'm just going to apply whatever we have got it here. Then we are going to find tan B. What is tan B? Right. Perpendicular by base. So perpendicular by base is 5 by 13. Isn't it easy now? Now we have found out sine, cos and tan. So what are the other 3 trigonometrical ratios? Right, they are cosec, sec and cot. So let us do that here. So the opposite of sine is cosec. So cosec is equal to cosec B is equal to, yes, the reverse of sine. So here we will be having hypotenuse by perpendicular. So which is just the reverse of that. You can directly write it as 13 by 5. Then let's find out sec B. What is sec B or secant B? Whichever is easy for you, you can tell that. Which is hypotenuse by base. I'm just going to write the reverse of this. Hypotenuse by base will be 13 by 12. And the reverse of tan is cot B. Which is base by perpendicular. So since it's perpendicular by base, here it is base by perpendicular. So this would become 13 by 5. Clear? Now is it very clear how to write the trigonometrical ratios with reference to angle B? Now we are going to do with reference to angle C, because that is also a question. I've done that. I've written that as an extra question so that you understand the difference between reference of angle angle B and angle C. Now I have drawn another picture. The same picture I've just repeated. Triangle ABC, right angled at A. And I've written the length of each side. Now we have to see the reference angle C. So for the reference angle C, which is the perpendicular, which is the opposite side, the 12 is the opposite side. So this is our perpendicular here. And the alternate side, that is 5. So this is our base. And this is our hypotenuse. So when we have the reference angle C, there is a slight change in base and perpendicular. Here the perpendicular is 5, base is 12. Here the base is 5 and the perpendicular is 12. So since this is with the reference of angle C, and hypotenuse will never change, it will remain the same. So now let's find it out. So same thing with sin C. So we are going to find out sin C. Sin C is equal to perpendicular by hypotenuse. So here our perpendicular is 12. So it is 12 by 13. And now let's find cos C. Cos C, which is base by hypotenuse, which is equal to, what's our base? 5. 5 by 13. And then tan. Tan C. Tan C is perpendicular by base. So perpendicular is 12. 12 by 5. Easy. The same thing we are going to repeat, but with a different base and different perpendicular. Now the same thing we are going to find the converse of it. So for the, what is the converse of sine? The opposite of sine is cosec or cosine. Whichever is easy for you, you can tell. So cosec C is the, just we have to reverse this. So it is hypotenuse by perpendicular. So hypotenuse by perpendicular will be, here we have 12 by 13. So here our answer will be 13 by 12. And the secant C, which is base by hypotenuse. So here we have 5 by 13. We can just directly reverse this as 13 by 5. Easy. Now tan C will become cot C. Cot C is, right, cot C is base by perpendicular. Base by perpendicular, we are just going to reverse the cot, which is 5 by 12. Isn't it easy? Now I think you have understood how to find the base and the perpendicular for the angle given, right? So if you found this video interesting and it was useful for you, do not forget to click on the subscribe button and hit the bell icon so that you get a regular updates of all my video. And if you liked the video, do not forget to hit on the like button. Now let's see the second question for today. So the question is, in a triangle ABC, right angled at B. So the main point to notice, it is right angled at B. If AC equals 5 centimeter, BC equals 3 centimeter, find sin A, cos C, tan A, cosec C, secant square A minus tan square A. So this is our question. So here A and C reference angle is mixed up together. So you have to be very careful in writing this. Now let's draw the figure for this question. So I have drawn this triangle ABC right angled at B. So the B is 90 degree here. Now what else is given? If AC is 5. So we know the hypotenuse side, which is 5 centimeter. And we know BC is 3 centimeter. Now we have to find out all these 5 questions. So now as you could see, there is one side missing, right? we don't have AB. So first let's find AB. So how are we going to find AB? Any idea? Right, we are going to use our Pythagoras theorem as we did it in our previous question. Now what is the Pythagoras theorem? Hypotenuse square is equal to sum of the squares of the other two sides. Right? Now let's use that. So here we would write AC square is equal to AB square plus BC square. Right? This is our Pythagoras theorem. So we know what is our AC. AC is 5. So 5 square equals, we don't know what is AB. We have to find our AB. This will remain as such. And BC square is 3. So there is 3 square. Now I'm going to bring this 3 this side. So 5 square is 25. Minus 3 square is 9. This comes this side. Whenever plus moves to the other side, it becomes minus. Equals AB square. Now 25 minus 9. What do we get? We get 16. 16 equals AB square. But we have to find AB. Squaring on both sides, this will be equal to square root of 16. So what is square root of 16? AB is 4. Yeah, 16 is a square number. So now we have got the value of AB. So AB is 4. Right? Till this it's clear. Now let's see the first question. We have sine A. So this is a reference to the angle A. So with reference to the angle A, which is our perpendicular side? The opposite side is our perpendicular side. So this is our P and this is our base because this is the adjacent side. So opposite side is the perpendicular, adjacent side which is nearby to it is a base, and as usual this is your hypotenuse. This will not change. So the first question, A question, is sine A. We have to find sine A. What is sine A? We have already learnt. So sine A is perpendicular by hypotenuse. So what is the perpendicular here? It is 3. So 3 by our hypotenuse is 5. So sine A, the answer is 3 by 5. Now when you see, we have cos C. Now we have to find with the reference of angle C. So with reference of angle C, our perpendicular and base will change. So now let's see which is our perpendicular. Let me change the color so that it is easy for you to identify. So now when reference with angle C, with reference to angle C, the opposite side is 4, right? This AB is the opposite side. So this becomes our perpendicular. So for reference angle C, this becomes the perpendicular. For reference angle C, BC becomes the base. I have written in green and that I have written in blue so that it helps us to check the difference between the numbers. Now let's do the question number B. What is our question? Cos C. We have to find cos C. So what is cos C formula? We have base by hypotenuse, right? So what is our base here? See this, you can see whenever we use the alphabet C with reference to the angle C, we will use with the green color. So our base is 3, that is BC. So 3 by 5, hypotenuse is same, so I have not differentiated. Hypotenuse is same for both the angles. Now again we have tan A. So now again we are going to do the reference angle A. So I've changed the color again so that you differentiate between these two reference angle. So now tan A. So what is the formula for tan A? Right, it is perpendicular by base. So what is our purple perpendicular here? This is 3 because that is with the reference of angle A. 3 by our base is 4. So it is 3 by 4. Easy. Now we have to find cosec C. Cosec C now with reference to angle C. So let's do the D question, which is cosec C. Cosec C is the reverse of which thing? Is it reverse of sine or cos? Yes, it is the reverse of sine. So reverse of sine is h by p. You just need to reciprocate it. H by p. So what is our h by p? We will see the green color. Which is our h? H is the common 5. And what is the perpendicular in green? This is 4. So you have to differentiate. If you're not able to differentiate with color, you can draw two diagrams and differentiate it. One angle with reference angle A, another reference angle C. Now our last question is secant square A minus tan square A. So this is little different. We have not used square so long. Now we are going to use the square. So our E question is secant square A minus tan square A. Now both are for A. What is secant square A or sec square A? Yes, that is the opposite of cos, which is hypotenuse by base. Hypotenuse is 5. 5 by what is our base here, which is in perpendicular base, which is 4. So it is 5 by 4, this square, because secant square, so I have just put a square, minus tan square. What is the formula for tan? Perpendicular by base. So perpendicular by base, already we have found a tan here. You can directly write it from there. So it is 3 by 4 the whole square. So now when you square this, we get it as 25 by 16 minus 9 by 16. And since these two are like fractions, we can directly subtract it. So 25 minus 9 is 16. So 16 by 16. So the answer is 1. 16 by 16 is a full fraction. So the answer becomes 1. So secant square A minus tan square A is 1. Isn't it easy? I have differentiated with the colors. You can refer that. And if this is confusing, you can draw a separate triangle for reference angle C. This will be little tricky still if you are doing few questions. Once you practice some more questions, it will be very easy for you to work it out. So I hope the basics of trigonometry, the very basic part of a trigonometry is clear for you. If you have any doubts in this particular topic, you can comment down in the comment section. I will try to clarify all your doubts. If you found this video interesting, click on the subscribe button and click on the bell icon so that you get a regular updates of all my video. And if you liked my video, do not forget to hit on the like button. And I would be bringing more parts of geometry, And I would be bringing more parts of trigonometry, and we will be solving more tricky questions in trigonometry. So stay connected. And thank you for watching till the end.